Today I'm going to show you how to move around game objects inside your inspector using something called translate and rotate. And that is something that we did kind of touch upon the last episode, but I didn't really explain it. So we're going to do it in this episode. And we're also going to learn how to make our game object look at another game object automatically as we're playing the game. So let's say you have a game where you want a enemy turret to kind of look at your player to shoot it. You know, it has to follow the player. Then you're going to learn how to do that in this episode here. So as you can see, I have a very simple player inside my hierarchy. I just created a square sprite and I attached a small circle to it and I just put it as a child so it would actually follow around the square, which means that if I were to actually move around my square, you can see that the little circle just kind of follows there. Now what I want to do is I want to go inside my code and I want to add a translate and a rotate in order to make this game object move around when I press my arrow keys on my keyboard. So I'm going to open up a script that I've attached to my player. And inside of here, the first thing we're going to do is we want to set a speed of how fast we want to move this player inside our scene. So I'm going to say that we have a float. I'm just simply going to call it move speed. And I'm just going to set this one equal to 10. And now inside my update method down here, I'm just simply going to say we have an if statement and say that if I were to press the upwards key on my keyboard, the upwards arrow, then I want to move the game object forward. So I'm going to say input dot get key. And then I want to tell it to look for a certain key code. And that is something where essentially all the buttons on your keyboard has a certain key code. So if I want to have the upwards arrow on my keyboard, then I can look it up on Unity's documentation to just kind of figure out what the key is. So in this case here, the key code for the upwards arrow is up arrow. And then I'm just simply going to go inside the curly brackets and say I want to grab the current game object that it's attached to, dot transform, dot translate, parentheses, and semicolon. Now, I know some people might be asking about this because it is something that I keep doing, but I know I don't have to. Essentially, because we're on this current game object with the script that we want to do something to, we don't need to add game object in front of it. But the reason I do so is because it just kind of creates logic when I explain this to people. You know, some people might not fully understand what we're referencing to here. So just to kind of mention it, we don't need the game object part in front of here, but just kind of like shows us that, oh, okay, so it's the current game object that we're on top of. Now inside translate, I need to give it two different values. I need to tell it which direction we want to move. And this also includes the speed, by the way, so we need to add that in from the speed that we set up here. And I also need to tell it in which sort of space do I want to move around in. So do I want to move around in a local space or in the world space? Which there is a difference, and I'll show you in a second what exactly the difference is. So inside translate, I'm going to create a new vector 2. Do keep in mind, if you're inside a 3D game, this would probably be a vector 3. But because I'm inside a 2D game, this is just going to be a vector 2. And I'm going to tell it that I want to move in a 0 along the x-axis, and I want to move it upwards along the y-axis. And that is just simply going to be the move speed that we have here. So I'm going to put that in there. And then afterwards here, we want to add time.delta time, which is something we talked about in the last video, why we want to do that. Essentially, if you don't do it, the game object is going to move super fast and it's going to fly off screen because we have a higher frame rate. So we're going to say multiplied by time dot delta time. Now, if I were to stop here, it is going to, as a default, just say that this is going to move around based on the local space of this game object here, meaning that the game object itself is going to be its own little world, and we're just going to move based on where the game object is, which is probably the effect that you're probably going to think we're about to do. So, but let me go ahead and just add it in here. So we're going to say space, and it's going to be the self space, which is the local space of this game object here. So if I were to do this, go inside my game, and actually click play. And if I were to press the up key, you'll notice that, oh, we're moving upwards, but we can't really do anything else. We're just moving upwards. So what I want to do is I want to go ahead and add in a rotation. So what I'm going to do is I'm just going to copy paste because I want to have another input, and we might as well just copy everything here. So the next one is going to be a key code for the left key, and you would probably guess it. It is just called left arrow. Now, we don't really need to change a lot about this code because it's very much the same thing. So we're going to say rotate instead of translate. And when it comes to the vector here, we do actually want to have a vector 3 because when it comes to rotations, even though we're inside a 2D game, we do still have 3 different axes that we want to rotate about. And it is actually the z-axis that is going to determine whether or not we rotate in the direction that we do want to rotate in when it comes to 2D games. So we do need to make sure we add in this vector 3. So in this case here, we want to move 0 on the x-axis. I do also want to move 0 on the y-axis because, like I said, it's going to be along the z-axis that we want to move. So not the move speed, but the rotation speed. So we can just say rotate speed and go ahead and add that in as a parameter at the top here, or as a field. So just going to say rotate speed is going to be equal to, let's make that 200, because that has to be quite a bit faster. And same thing here, we do need to multiply by time the delta time, otherwise it is going to rotate about super fast depending on the frame rate. And we do also have something called space.self or space.world. Now this is going to be the left direction, so let's go ahead and add in the right direction too, just to have it here. So we're going to say input is going to be the right arrow on our keyboard. And we're also going to make sure that we set our rotation speed to a negative because we want to rotate the other direction. And that is simply all we need to do here. So I'm going to go inside Unity, press play. And with my arrow keys, you'll now notice that we can actually rotate and we can move forward. So we can rotate and run around like a little car. This is called tank controls, by the way, where you move around and you have to like rotate your character to kind of like get from A to B. Now, what you're going to notice is that if I were to press the upwards key on my arrow keys, I'm going to move to the right. And that's because my character right now is facing the right side, and I can also go to the left side. When I talked about the local and the world space, this is going to tell us whether or not we want to move these directions based on what the game object itself is facing, or what the world space is. So if we were to look at this in a different way, let's actually go ahead and say we want to move forward in a world space instead of a local space or self space as it's called in here. If I were to go back inside the game and play, you'll actually notice that if I were to rotate my player and click forward, I actually move upwards. And that's because the world space inside our game is, just kind of fixed. So upwards is always going to be that way. Whereas on our player, upwards right now would be to the left side, right? But the world space is always going to be upwards. So if I were to set the moving direction to the world space instead, we're always going to move upwards no matter which direction I'm facing. And that also goes for when we talk about rotations. However, in order to demonstrate what I mean by the world space in rotations, we do actually need to go into 3D mode to kind of see what is going on. So if I were to go down here and just set the left direction to the world space instead, and keep the right direction as the local space. If I were to go back inside Unity and just kind of move my game view over here to the right side so we can see both of these, because we do actually need to kind of see what is going on behind the scenes, and we also do need to see the actual game. If I were to actually go ahead and toggle off 2D mode up here in the left corner, go in, you can now see that this is our game object, right? This is how the scene looks like in a 3D space when it comes to a 2D game. So it's just kind of like, it's just kind of like flat there. If I were to actually go in and press play, and I'm going to be moving to the left side, you're going to notice that nothing is really happening. It's still the same. Everything is working fine. We can move left and right. However, if I were to take my game object and actually rotate it in another direction, let's say I take the x-axis and move it like this, you can kind of see that inside our 2D game, it kind of looks just like I'm squishing it. But in the 3D space, you can kind of see what is going on here. I'm just kind of tilting my game object. If I were to start rotating it now, you can actually see what is going on when we talk about rotating according to world space versus local space. So if I were to spin to the right side, which is in local space, and just kind of spinning like a disc. It's rotating like I want it to, but if I do it to the left side, I rotate it like this. And that's because along the world space, we can kind of like draw a, let me actually go ahead and do that. Okay, so I went ahead and created a white square just to kind of illustrate my point here. If I were to rotate my game object, along the local axis, it is just going to spin like this, It's not really doing anything in terms of like the white square. It's just kind of like rotating, like we want it to. But if I were to go ahead and do that in the world space, it rotates along the axis of what the white square is. If that kind of makes sense, like this. For some people, wrapping their heads around what local space and world space is can be a little bit confusing. So I'm trying to do my best here to just kind of illustrate what I mean by that, that it rotates along the world instead of itself. So with that, let's go ahead and delete this white square that I just created. and go inside our code and just set it back to local space because we don't need to have it along, that weird space there. So talking about that, let's go ahead and talk about how to look at other game objects inside our game, just so we have something that can kind of follow along our player or something. So what I did, and you probably noticed it, I have another game object that I actually deactivated inside my game here. If I were to toggle that on so we can actually see it, you can see, oh, we have another game object up here. This one is going to be a turret, like a cannon that kind of like follows the player. And what I want to do is I want this to look at my player as my player is moving around inside my game. So currently I have this script here attached to that turret. And what I want to do is, first of all, I want to go ahead and create a transform that is going to be the location of where my player is. So I'm going to say that we have a transform type. And I'm going to set this one to target because the player is going to be the target here. And I want to make sure that this is a serialized field. So I can actually drag and drop my player into so it becomes the target. So I'm going to say serialize field. Now inside Unity, we do have a built-in method that is called LookAt. And when it comes to 3D games, this is a very amazing method to be using if you want something to look at another game object. However, when it comes to 2D games, it doesn't really work, and I'll show you why. So if we were to go inside our update method here, and I'm just going to say that I want to reference to the game object. Again, this is kind of unnecessary, but just so people know what we're referencing to, game object dot transform dot lookat parentheses. And essentially all we need to do here is we just need to copy the target and put it in here. Now there is a second parameter in here, which is going to be which direction we want this game object to face as it's turning towards our target. We don't really need that in this example here, so just go ahead and paste in the target. And what I'll do now is I'll go inside Unity, I'll click on my turret, and I'll drag my player character inside the empty slot for the target, because we need to do that first. Save it, and press play. And then just kind of see what happens here. Our game object disappears. That's kind of peculiar. It should be following my player, but why isn't it? If you look inside the actual game scene up here, behind the scenes type thing, you can actually see that we still have the game object, but what is kind of going on here? If I go into 3D mode, you'll see that we are actually facing the player, but we're doing so in the set direction. And that's because as a default, the set direction is going to be set as forward when it comes to looking at certain game objects, kind of like how my eyes are sitting in front of my face. So that is going to be forward in my case. The eyes of this player is going to be as a default on the Z axis, which means that when I move around my player, it is following me, but we can't see it inside our 2D game because it's kind of flipped along the Z axis here. So we can still see the game object, but not really, because it's super thin. So we're looking at it from the side here, which isn't going to show up inside our 2D game. So how do we fix that? Again, like I said, in a 3D game, this would be the solution to do this, but because we're inside a 2D game, I do need to go and do this in a slightly different way. The first thing we're going to do is we're going to create a offset. And we talked about that in a previous episode where we talked about how to mess around with vectors inside our games. So we want to get the offset between these two different characters or these two different game objects. So we're going to say we want to create a vector 2, which is going to be direction. If I can spell that, there we go. And we're just simply going to minus the position of these two different game objects to get the offset. So in this case here, we have the target dot position. And just to mention it, we don't need to put in transform in between these two. We've done that any other time we've done this, but the reason we don't have to do that today is because we're already referencing the transform of the target. So the target here is the transform that we're grabbing. So target.position is going to be minus to our game object, which we learned we don't need to type in game object first. So we just need to say transform dot position, like so. So now all I need to do is I need to actually tell it, the game object that this script is attached to rotate a certain direction based on the offset. So what I'll do is I'll jump down to the next line and I'll say that we want to get the transform dot rotation. And I'm going to set this one equal to quaternion. Now, whenever we want to set a rotation, we want to set something equal to a rotation, we use quaternion, which is the word for rotation. So in this example here, I can actually go ahead and say I want to run a certain method on this rotation here. So we're going to say from to rotation, parentheses, which is essentially going to rotate the game object from a certain location to a new location. And we just do that every single frame in order to, allow for this game object to do that. Inside the parentheses, we have two different parameters we need to add in. The first one is going to be which side of this game object that we're attached to do we want to face towards the target. In this case here, it is the top of the game object, which is the Y direction. And the second parameter is going to be which direction do we want to point inside our scene, which is going to be the direction that we found up here using the offset. So going inside the parentheses here, we could write new vector 3 parentheses, and then add in a 0 on the x-axis, a 1 on the y-axis, and a 0 on the z-axis. However, this is kind of a long way to write this. Another way you can write this, if you just need to have a 1 on one of these different locations here, because we're talking about a direction, is we can write a shorthand, which is vector 3 dot up. And that's the exact same thing as writing what I just wrote. And you can actually see when I hop on top of it, it says it's a shorthand for writing vector 3, 0, 1, 0. And you can do this with any direction. If I want to go to the right side, which means that we're going to the 1 on the x-axis and then 0 in the other ones, we can actually write right, which is going to be the exact same thing. It's going to be 1 on the x-axis. If I want to go towards the back, I can just go ahead and write back. I can also go forward, which is going to be along the z-axis. So you can actually see it's the same as writing 0, 0, 1. So we have a couple of different shorthands that we can write if we just want to talk about a certain direction using vector 3s. So in this case here, we're just going to go ahead and say dot up, because we're talking about the y-axis going upwards. And again, just to kind of illustrate why we want to set the y-axis, it's because my player right now is pointing upwards. So that's my looking forward direction. And in the same sense, if I were to have my game object inside my scene facing the right side, then the right side would be the facing direction. So we'd have to say dot right instead of dot up, just to kind of mention it there. So going back inside my code, we want to add in the second parameter, which is going to be the actual offset. So we're going to say direction, paste that in, save it, press play. And what you'll notice now is that I'm actually going to be facing, or my turret is going to be facing my game object as I start moving around. And this is kind of what we were hoping for when it came to getting this little facing direction effect here inside a 2D game. So this is how we can do that in a very simple manner. Just kind of a last thing to mention here, because some people might mention this. Let's say I play the game and I'm not moving at all with my player. Like, let's say, I'm not moving. I'm just kind of standing still. The turret is still going to be constantly updating its rotation, even though it's not supposed to rotate because I'm standing still. And that is not really a good practice inside the code. So essentially inside my code, I could put in a if statement here that would say, if our current offset is the same as the previous offset in the previous frame, then don't update our rotation, because there's no need to. So what I can do in here is I could go in and say we have the if statement. I want to create a new field up here that is called something like vector 3 as a type, called last rotation, just to call it something. And then at the very end here, we're just going to update our rotation. So we're going to say our last rotation is going to be equal to the direction. Now, essentially, we're not really looking for the last rotation. We're looking for the last offset, because if my player moves, then the offset is going to be different. But we just want to set it equal to the last direction, or the last offset here. And then we simply run a check here that says if our last rotation is not equal to the current rotation. And we are talking about a 2D game in my example here, so we do actually need to put this as a vector 2. But if you're talking about a 3D game, this would actually be a vector 3, just to kind of mention it there. And then we just simply put in the code here. So this line of code would actually go inside the if statement, like so. And just to kind of test this, let's actually go inside the if statement and say a debug.log, and just kind of write test. And if I were to go inside Unity and press play, you can see that if I'm not touching anything, it is going to update one time, which is going to be the first time it has to, reset itself to point towards my player. But it's not updating anymore. It's not actually running the rotation code, because we're not getting anything else inside the console. If we were to press upwards, then, it starts updating. Nothing when I rotate, by the way, because we're not moving around the offset. But if I were to actually continue moving, then it will actually start updating again. So just to kind of avoid any sort of redundancy happening, using if statements in this type of way to make sure that we still check for the last position of the player inside our game, is just going to help you with performance inside your game. So with that said, we talked about how to actually move your player, how to rotate your player, and we also talked about how to look at your player. So I hope that was kind of interesting to sort of follow along. So with that said, I hope you enjoyed, and I'll see you in the next video.